Welcome to the deep dive. We're jumping in today on a service tackling, well, a massive challenge, something almost every organization faces, right?
Absolutely.
Turning these mountains of documents, you know, invoices, contracts, forms, scanned paper, PDFs, everything,
Yeah.
into data you can actually use. Structured data.
Yeah, it's like trying to find not just one needle, but all the important bits in this huge digital haystack.
Yeah.
Doing it automatically, fast, and at scale.
Exactly. So the service we're looking at today is Azure AI Document Intelligence. We've done a pretty deep analysis, looked at a whole stack of research on its capabilities, its value.
Right. And our mission really is to unpack the most important stuff from all that so you can get up to speed quickly on what really matters here.
Perfect. So let's start at the beginning. What actually is Azure AI Document Intelligence? Why is it so relevant now?
Okay, so at its core, it's a cloud service from Microsoft, AI-powered. Some folks might remember its old name, Azure Cognitive Services Form Recognizer.
Right. Form recognizer.
Yeah, same thing, evolved. Its main job is to use advanced machine learning stuff like optical character recognition, OCR, but also deep learning to look at documents, understand them, and pull out the key info.
So it's way beyond just basic OCR, just reading words off a page. It's about the context, the structure.
Precisely. That's the key difference. It reads the text, sure, but it also gets the layout. Where are the tables? What are the form fields, the sections?
Okay.
And it does this using, well, a couple of ways. It has pre-built models ready to go for common things like invoices or passports. But crucially, it also lets you build custom models tailored just for your specific business documents.
And why is that such a big deal for businesses right now? The strategic value?
Well, it's fundamental for intelligent automation, digital transformation. Think about how much time people spend just typing stuff from documents into systems.
Ugh, yeah. Manual data entry.
Exactly. This service can slash that. The analysis we looked at mentions like up to 90% reduction in manual effort for some processes.
Wow, 90%.
Yeah. And it's not just saving time and money. It boosts accuracy, fewer human errors, right? And speeds up workflows everywhere. Finance, healthcare, legal. I mean, anyone dealing with piles of documents.
It feels like it wouldn't live in a vacuum, though. Is it designed to connect with other things?
Oh, absolutely. That's a huge part of its value. It's
Right.
built to plug right into the Azure AI ecosystem, so you can easily link it with Azure AI Search, Azure OpenAI, Azure Machine Learning,
Okay.
which makes it this vital building block for more complex end-to-end solutions. Especially important now for powering those advanced RGAG applications, retrieval augmented generation, that need to understand knowledge buried in documents.
And the performance, the source mentioned, it's pretty accurate and scales well.
That's right. The analysis points to extraction rates often hitting over 80% first time round, even with scans that aren't, perfect quality. And yeah, it's built for scale, batch processing for big jobs, and something called provision throughput units, or PTUs, that lets you reserve dedicated processing power for predictable, heavy workloads.
So you get that consistent speed even when you're hitting it hard. What about how you actually get it and use it? Is it flexible?
Very flexible. There's a free tier to kick the tires, then pay as you go, which scales with your usage. Or for bigger, steadier needs, commitment tiers give you discounted rates.
Okay.
And this is important, they offer disconnected containers. That means you can run the service right inside your own data center on premises.
Oh, interesting. For data residency stuff.
Exactly. If you've got strict rules about data not leaving your network, this is a major plus. You use the cloud-trained smarts, but the data stays put.
And for sensitive industries, finance, healthcare security must be paramount.
Definitely. It's built on Microsoft's responsible AI principles. Things like fairness, reliability, security, privacy, transparency, all that. The source notes it has strong security features, compliance certifications, making it suitable for those regulated environments.
Okay, that's a great overview. Let's peel back the layers a bit. The core capabilities. The analysis breaks them down into document analysis, pre-built models, and custom models, right?
Right. Let's look under the hood. It starts with the document analysis models. These are the foundations, the read model and the layout model.
So the read OCR model, what's special about it? How is it different from just any old OCR?
Think of read as like supercharged OCR. It's optimized for high resolution, Built for dense text, small print, across lots of formats, PDFs, images, Word files, even HTML.
Higher resolution helps with accuracy.
Significantly, especially on less than perfect documents. It doesn't just grab text. It identifies paragraphs, lines, words, where they are on the page, and the language. It's the engine powering everything else.
Finding and understanding the words, and version 4.0 added something extra.
Yeah, a pretty neat trick noted in the source. It can generate searchable PDFs directly from images or scanned PDFs. Right as part of the analysis, and at no extra cost.
Oh, that's genuinely useful for making old archives searchable.
Exactly. Quick win.
Okay, so Reed gets us the words. What does the layout analysis model bring to the party? How does it go deeper?
Layout takes the text from read and adds the structural understanding. So it extracts the text plus the structure around it. Checkboxes, they call them selection marks. Tables, even complex nested ones, styles like headings or bold text. Paragraphs, all mapped out with their precise locations, their bounding boxes.
It's understanding the visual arrangement.
Right. And the source mentioned it can now handle key value pair extraction too, like finding invoice number and then the actual number next to it.
Yeah, it seems you can use the layout model, add an optional query, and pull out specific key value pairs. Sort of replaces the older general document model for that kind of task.
Okay.
But here's where it gets really interesting, especially for things like RAG.
Uh-huh.
The layout model can output all this structured info as Markdown.
Oh, Markdown. Why is that significant?
Because large language models, LLMs, understand Markdown really well. It helps them grasp the document's hierarchy, the sections, the tables, how things relate. Crucial for pulling out accurate knowledge.
Right. That makes sense. That bridge to LLMs is a big deal. Okay, so we've got text and structure covered. What about standard documents? Like everyone processes invoices, right?
Exactly. That's where pre-built models come in. These are models Microsoft has already trained on tons of examples of common document types. They keep them updated so you don't have to train anything yourself for these standard forms.
Just use them out of the box.
Pretty much.
And the list in the source looked pretty long. What kinds of things are covered?
Oh yeah, quite comprehensive. Lots in finance. Receipts, invoices, and it supports different languages and formats there, like Japanese or UAE invoices. U.S. bank checks, bank statements, pay stubs, credit cards.
Okay. What about ID and tax stuff?
Yep. U.S. driver's licenses, the main page of international passports, and a bunch of U.S. tax forms, W-2s, 1040s, others.
Legal documents? Mortgages?
There's a pre-built model for contracts, designed to find things like the parties involved, the title, the date, also specific U.S. mortgage docs and marriage certificates.
Any others that stood out?
A model for U.S. health insurance cards. The source did mention the business card model is being deprecated in v4.0, but it was there before.
Wow, that covers a lot of common ground. Quick way to automate standard processes.
Exactly. Fast track for those common scenarios.
But, okay, what if my documents are unique to my business, like a proprietary form we use internally? Nothing pre-built fits.
That's the sweet spot for custom models. If your documents have unique layouts, or you need specific info that's not in a pre-built, you train your own model.
How does that work?
You use your own documents as examples. You label them usually using the Document Intelligence Studio tool, basically pointing out this is the field I want, this is the table.
You teach it what to look for in your docs.
Exactly. And the analysis mentioned two types of these custom extraction models.
Yeah, template models and neural models. What's the difference?
Template models are best when the layout is super consistent, really static, like a printed form that never changes. Neural models use deep learning, so they're more flexible. Better for documents where the layout might vary a bit, different versions of a report, that kind of thing. Semi-structured docs.
Okay, neural for more variety.
Right. And a powerful feature is that you can train several custom models, maybe for different versions of a form, and then combine them. Create a single composed model that figures out which underlying model to use for any given document it sees.
Ah, clever. So it handles variations under one umbrella. What about just sorting documents? Figuring out what type of document you're even looking at?
Yep, there's a model for that too. The custom classification model. You train it to recognize different types of documents based on their look and language. Super handy for sorting an incoming pile, like automatically sending invoices one way, purchase orders another.
That makes sense. Routing them correctly. And can you update these classifiers?
Yes. The source mentioned incremental training is supported, so you can add new examples over time to make them better.
And for people who aren't hardcore developers, how do they build these custom things?
That's where the Document Intelligence Studio comes in. It's a graphical tool, Web-based, you can use it to explore the service, visually label your documents, train the models, test them, deploy them, even just try out the pre-built ones. Makes it much more accessible.
Okay, good. And there was a mention of add-on capabilities, like optional extras.
Exactly. Features you can turn on for more specific analysis needs. Things like high-resolution OCR for really tiny text, extracting mathematical formulas, detecting font styles, reading barcodes, identifying languages, better key-value pair extraction, using query fields where you ask natural language questions to get data.
Query fields, interesting.
Yeah. And that searchable PDF generation we talked about, though that one's free with the read model. Important note. Enabling some of these add-ons might add to the per-page cost.
Right. Pay extra for the extra capability. Makes sense. Okay, we get the what. How do you actually plug this into your applications? The technical side.
Okay, yeah. The main ways are using its REST API directly, or more commonly for developers, using the SDKs, the client libraries.
And which languages do the SDKs support?
The analysis listed .NET, so C#, Python, Java, and JavaScript. Plus, for managing the service itself, PowerShell and the Azure CLI.
Got it. Authentication always key. How do you connect securely?
You need two things: your service endpoint URL and a credential. The easy way, especially for getting started or testing, is an API key credential.
Simple, but maybe not for production.
Exactly. For production, the strong recommendation, really emphasized in the source, is to use Microsoft Entra ID, what used to be Azure Active Directory, identity-based auth.
Right, integrates with enterprise logins. And the analysis made a point about needing a custom subdomain for Entra ID with Document Intelligence. Why is that specifically important?
Yeah, that's a key detail. Unlike some other Azure services where you might use a regional endpoint, Document Intelligence requires you to set up a custom subdomain name for your resource if you want to use Entra ID authentication.
Why the requirement?
It's actually a security and governance thing. It ties that secure, identity-based access to a unique endpoint under your organization's control. Better security posture, easier governance, fits better into existing enterprise security frameworks. It's not just a technical hoop, it's a strategic choice for better security.
Okay, so custom subdomain is key for Entra ID. And setting that up involves...
Typically, you register an application in your Entra ID, create what's called a service principal for it, and then you grant that service principal roles on your document intelligence resource. Like the cognitive services user role lets it analyze documents.
Makes sense. Standard Azure pattern. The source also liked the design of the client library, splitting them into two classes.
Yes, that was highlighted as a good design choice. There's the document intelligence client. That's the one you use for the main job, actually processing documents, calling methods like analyze document or classify document.
Okay, the doing client. And the other one?
Is the document intelligence administration client. This one's specifically for managing the service and your models. Things like building custom models, listing them, deleting them, copying them between regions, creating those composed models.
Ah, so separation of concerns, one for using, one for managing.
Exactly. It supports the principle of least privilege. An app just processing invoices doesn't need permission to delete your models, right? Better security, easier auditing.
Good point. And for developers wanting to start coding, resources available.
Oh yeah, tons. Microsoft provides detailed documentation, quick starts, lots of sample code on GitHub covering different scenarios and languages.
What about long-running tasks, like analyzing a really big PDF?
Yep, the SDKs handle that. They support both synchronous calls for quick things and asynchronous operations for longer tasks, like analyzing large documents or training models. They have built-in pollers to make it easy to track the progress of those async jobs. And the client objects themselves are thread-safe, which is good for building high-throughput apps.
Okay, solid developer story. So we know what it is, how to connect. Now the important part. How well does it actually work? Performance, accuracy, scalability, the so what?
Right. Let's revisit that OCR quality from the read model. Because it's specialized, high resolution, it gives you that superior precision, especially compared to just general OCR tools.
Which leads directly to those high accuracy numbers.
That's the idea. The source mentioned common accuracy over 80%, and that specific example of an 85% hit rate for remittances, meaning 85% were captured correctly first time, no human needed.
But 85% isn't 100%. How does it help you deal with the ones that aren't quite right or that the model isn't sure about?
That's where confidence scores are absolutely crucial. The model doesn't just give you the data. It tells you how confident it is about each piece. It gives a score, usually 0 to 1, for the document type it identified, for each field it extracted, even down to individual words and checkboxes.
Okay, confidence scores. Why are they so important in practice?
because they enable what's called a human-in-the-loop workflow. This is really key. You set a threshold. Maybe say, if the confidence for this field is above zero point 0.8 or 80%, just process it automatically.
Okay.
But if it's below that threshold, flag it. Send it to a human operator to quickly review and correct if needed. For really sensitive data, like financial amounts or medical info, you might set that threshold much higher, like 95% or even near 100%.
So it's not trying to be perfect AI, it's smart automation with safety nets. You automate the confident stuff, humans check the uncertain stuff.
Exactly. It's pragmatic. It balances efficiency with the need for accuracy and compliance, especially in areas where mistakes are costly. Augmentation, not just blind replacement.
Makes total sense. And input quality still matters a lot for accuracy, right? Garbage in, garbage out.
Absolutely. The source hammered this point home. Clear scans, good photos lead to the best results. Text-based PDFs are better than image-only scans. And there are practical limits, like it can handle up to 2,000 pages in one go for PDF-TF.
Okay. And scaling up. Beyond the default 15 requests per second.
You could request an increase through support. For handling large volumes efficiently, there's a batch analysis API. Lets you submit big piles of documents for offline processing.
And for those really high predictable volumes.
That's where the provision throughput units, PTUs, come back in. You basically reserve dedicated processing power, guarantees consistent performance, and can actually be cheaper than pay-as-you-go if your volume is high and stable.
Like reserving a dedicated lane on the highway.
Kind of like that, yeah. And there are auto-scaling options, too, for custom models you deploy so capacity adjusts based on demand.
Okay, so overall performance and quality depend on, well, a few things. The model itself, the quality of the documents you feed it, the quality of your training data if you build custom models, picking the right model for the job, how well you integrate it, and crucially, having that validation step, that human review based on confidence.
Right, which flows nicely into the real-world impact. We know the tech, the performance. What are people actually doing with this? What are the compelling use cases?
Well, the big picture is automating data extraction and archiving at scale, getting people away from mind-numbing data entry, turning documents into data you can search and analyze.
Let's get specific. Finance seems like a huge area.
Oh, yeah. Loan processing is big, pulling data from IDs, pay stubs, income statements. Invoice processing is massive, enabling things like automated three-way matching against purchase orders and receipts, speeding up payments. Plus, extracting data for fraud detection or risk models.
The source had a specific bank example.
It did. A major international bank reportedly cut document processing time by 65% and saved around $2.3 million annually using document intelligence. That's serious ROI.
Wow. Okay. What about healthcare?
Patient onboarding, billing, digitizing forms, pulling data from insurance cards. Remember that pre-built model. You can also send the extracted text over to Azure AI language services to pull out specific medical terms or insights from clinical notes.
And legal. All those contracts.
Definitely. Extracting key clauses, terms, party names, dates, amounts from contracts speeds up reviews significantly, even if the scans aren't perfect.
Any other industries?
Retail uses it for scanning receipts. Governments for digitizing forms and tax records using those pre-built tax models we mentioned, improving efficiency, citizen services. But here's where it gets even more powerful, I think. The integration with the rest of the Azure AI ecosystem. It's not just a point solution, it's part of a bigger platform.
Right. How does that integration add value?
Okay, so you extract the structured data. Now you can send it straight into Azure AI Search. That indexes it, makes it instantly searchable, and that is the foundation for building those RA applications or conversational AI bots that can answer questions based on your documents.
So you can basically chat with your company's knowledge base.
Exactly. Game changer for knowledge workers. And you can do other things too. Store the data in databases like Cosmos DB. Use it to train other machine learning models in Azure ML, maybe for predicting fraud. Send the text to Azure AI language for PII detection, sentiment analysis, or specialized health analytics.
And connect it to the big language models like GPT-4.
Yep. Pass extracted summaries or data to Azure OpenAI for more processing, maybe checks and balances, or building generative AI apps. You can even use multimodal models in OpenAI to help with text extraction from images first, then visualize it all in Power BI. And the apps controlling this whole flow host them on Azure Functions, App Service, Kubernetes.
So the ecosystem isn't just nice to have, it unlocks much more complex solutions.
That's a real leverage. Less integration headache if you're already on Azure, unified security, and enable these powerful downstream uses like knowledge mining.
Sounds amazing, but
yeah,
practicalities. Cost. How does the pricing work? Is it complicated?
It's designed to be flexible, tiered. The analysis laid it out pretty clearly.
What are the main options?
Starts with free tier, F0. Good for trying things out. You get up to 500 pages process free per month.
Okay, 500 free pages. Then what?
Then the main model is pay-as-you-go, S0. Simple. You pay per page processed.
And the costs vary depending on what you're doing, right?
Okay.
Can you give some examples from the source?
Sure. The basic read model for just OCR starts at $1.50 per thousand pages and gets cheaper at high volume, down to like 60 cents per thousand. The pre-built models, invoices, receipts, etc., are $10 per thousand pages. Custom classification, just identifying the document type, is $3 per thousand.
And the custom models you train yourself, the extraction one.
Those are pricier, reflecting the tailored value. Custom extraction and the newer custom generative extraction are $30 per thousand pages.
Okay, quite a jump.
Yeah. And those add-on features we mentioned, like barcode reading or formula extraction, typically add another $6 to $10 per thousand pages on top. Training also has costs. Template model training is free, but neural model training costs $3 per hour after the first 10 free hours each month.
So there's a definite cost difference based on the complexity and value. Custom is most expensive. What about those commitment tiers for volume discounts?
Right. If you know you'll be processing a lot consistently, you can commit to a certain volume monthly or annually and get lower per page rates. The source gave examples like maybe $540 a month for 20,000 custom extraction pages in Azure, or $375 for 500,000 read pages.
And the disconnected containers for on-premise.
Those are priced annually based on commitment. An example from the analysis was around $24,480 per year for 1.2 million custom extraction pages deployed on-prem. Gives you the volume discount plus data residency. So thinking about the total cost, it really depends on how many pages, which models you use, because custom is much more expensive per page, whether you need PTUs for consistent speed, storage, region, training hours, and add-ons.
Seems like the pricing kind of guides you towards using the cheaper options like read or pre-built first, and only using custom extraction when you really need that specific tailored capability.
Yeah, that seems right. It's a value-based approach.
Okay, we've got a good picture of document intelligence itself. How does it compare to other players out there? The IDP market. The source had a competitive analysis section.
It did. And just to be clear, this is based only on the perspective presented in the source material. We're reporting what the analysis said.
Understood. So first up, how does it stack against AWS TechStract, another big cloud provider?
According to the source, Azure's strengths are seen as better integration in the Microsoft world, more flexible custom training, maybe better multilingual support, better understanding of context within the document, and models that learn faster. The analysis suggested Azure might offer better value for complex workflows.
And TechStract's strengths.
Highlighted as strong on automating text data extraction beyond basic OCR, very scalable, easy AWS integration, and a potentially cost-effective pay-as-you-go model for certain uses.
Any weaknesses noted for TechStract in this source?
Yes, it mentioned TechStract might be less accurate than Azure, especially with handwriting, and perhaps have fewer out-of-the-box workflow capabilities compared to Azure's ecosystem plays.
Pricing comparison.
The source put AWS TechStract around $1.60 per thousand pages versus Azure's base read model at $1.50 the thousand, but remembering Azure has those different tiers and model prices.
Okay, what about Google Document AI?
Similar comparison points. Azure's strengths, again noted as MS ecosystem integration, flexible custom training, competitive pricing, strong multilingual. Google's strengths were highlighted as its ability to extract, classify, and split documents, a unified management experience for models via their workbench, and being effective for some specific document types like manufacturing docs.
Pricing.
Source indicated Azure's base around $1.50 per thousand, Google's around $1.75 per thousand. Again, small difference per page, but adds up at scale.
Other feature notes.
Analysis mentioned Azure often needs labeled data for custom models. Google has its workbench approach. Azure's structured output with confidence scores was noted as a key feature.
Moving beyond the big cloud providers, UiPath document understanding. Big in the RPA space.
Right. The source saw Azure as comprehensive, intuitive, cost-effective, highly accurate, using that 85% example again, and easier to integrate and deploy than UiPath. UiPath was recognized as a strong IDP player using OCR/ML, reducing manual effort, integrating for handwritten signatures around 70% success noted there, plus pre-built algorithms and human in the loop.
UiPath challenges, according to the source.
Mentioned potential issues with handwriting accuracy compared to others, handling diverse templates, integration complexity. Also noted UiPath might need training for all document types and could be seen as having a high license cost.
Okay, finally, the more traditional established vendors like ABYY and Kofax.
Against them, the source again positioned Azure as comprehensive, intuitive, cost-effective, accurate, and easier to integrate compared to, say, ABYY FlexiCapture.
But what are ABYY's strengths, per the source?
ABBY was called out as a leader with very high OCR accuracy, especially on complex documents supporting over 200 languages. And crucially, the source highlighted its ability to handle handwritten text easily, which was a challenge noted for others. ABBYY offers cloud, on-prem, hybrid, lots of customization, workflow engines.
ABBYY weaknesses.
Mention complex upgrades, documentation sometimes lacking detail, potential connection issues, and generally perceived as having premium pricing.
And Kofax.
Also a leading platform offering broad end-to-end automation capture RPA workflow. Uses advanced ML for complex unstructured docs, strong mobile capabilities, but the source noted Kofax is generally seen as more expensive as a full platform and often needs significant configuration work. It's really interesting seeing the different angles in that competitive view. The cloud natives push integration and scale. The traditional players often excel in deep customization, workflow, and sometimes specific challenges like handwriting, but maybe with more complexity or cost.
And that disconnected container option for Azure really stands out as a differentiator for certain industries, offering that on-premise deployment capability that not all cloud solutions have.
Absolutely. Big deal for regulated sectors.
Okay, so drawing all this together,
Huh.
what are the key best practices? If someone wants to use document intelligence effectively, what should they focus on? How do you make it work well for you?
The analysis had some clear, actionable advice. Especially around custom models, the absolute number one thing is data quality.
What does good data quality look like for training?
Starts with the input docs.
Yeah.
Clear scans, good photos. Text-based PDFs are always better than image scans if you have them. Use complete documents for training, not just snippets. Make sure you have diverse examples of the values you want to extract. The source suggested maybe 10-15 images per distinct layout, especially if quality varies. Keep your data organized, no password locks. Check basics like image size, text height. Make sure the model can actually read it.
And picking between template and neural custom models.
Key decision. Template for rigid, fixed layouts. Neural for more variation, semi-structured docs. And a really critical best practice from the source. If you have documents of the same type, but with different layouts, maybe different versions of a form over time, don't try to train one model on all of them.
What should you do instead?
Segment them. Group the documents by layout. Train a separate custom model for each distinct layout. Then combine those models into a single composed model. That composed model is smart enough to route incoming documents to the right underlying model. Way more accurate than one model trying to learn too many variations.
Got it. Segment and compose for layout variations. And this service is being pushed for a RAG, retrieval augmented generation. Best practices there.
Yes, definitely highlighted. Key technique is using the output from the layout model for semantic chunking.
Semantic chunking? What's that?
Instead of just splitting document text into chunks of, say, 500 characters, you split it based on the meaningful structure the layout model finds, headings, paragraphs, tables. This gives the downstream LLM much better, more relevant context when it's trying to find answers in the document.
Chunking by meaning, not just size.
Exactly. And related to that, using the Markdown output from the layout model, we mentioned LLMs understand Markdown well. That helps them interpret the structure accurately for RAG. The source points to sample code, accelerators using things like LangChain with document intelligence to build these RAG pipelines.
Okay. Any other general implementation tips?
Reiterate, high-quality import is king, and strongly, strongly implement that human-in-the-loop validation based on confidence scores. It's not a failing. It's essential for data integrity, compliance, and building trust. Optimize the workflow using the SDKs, host the back-end logic on scalable Azure services like Functions or App Service.
What about the responsible AI side?
Right. Keep those principles in mind: fairness, reliability, privacy, etc. Be aware of potential biases in your training data or how the model is used. It's about mitigating risks.
And security best practices.
Use those custom subdomains. Use Microsoft Entra ID for auth, especially in production. Really stressed in the source. Have sensible data retention policies. Use audit logs for governance. Remember, Microsoft states they only use your data to provide the service, not for other purposes, all crucial for regulated industries.
Okay, we have definitely covered a lot of ground here,
Yeah.
from the basics, capabilities, integration, performance, uses, cost, competition, best practices.
Yeah, I think the picture that emerges from this analysis is that Azure AI Document Intelligence is, well, a really powerful and evolving service. It's clearly more than just OCR. It's positioned as this foundational AI service for enterprises wanting to automate and really unlock the value hidden away in all their documents.
Key strengths seem to be those robust capabilities, the deep Azure ecosystem integration, especially for RG, the high accuracy reports, scalability, flexible pricing, including that unique disconnected container option, and the strong focus on security, compliance, and responsible AI.
And the recommendations coming out of the analysis are pretty clear too. Start with pre-built models if they fit. If you need custom, train them rigorously, focus on data quality, segment by layout, use composed models, absolutely implement human in the loop. Optimize cost and scale using the right tiers, PTUs, batch processing. Leverage the Azure ecosystem integrations. Prioritize security, enter ID, custom subdomains, and be mindful of responsible AI.
Looking forward, the source mentioned continuous updates, more languages, new features, and especially that focus on RGAD optimization.
Yeah, it really suggests document intelligence is going to become even more central for knowledge mining, for letting generative AI understand and work with your organization's specific documents. It seems poised to handle even more complex stuff down the line.
It really is fascinating, isn't it? Seeing documents shift from being these static things stuck in folders or filing cabinets to becoming dynamic, active sources of knowledge you can query and interact with.
Absolutely.
So as you listen to this, think about the documents you deal with every day. That messy handwritten note, the complex multi-page contract, the form that people fill out differently every time. How does the ability of AI like this to handle those nuances, combined with that essential human oversight for accuracy, how does that change what you thought was possible with automation and knowledge discovery in your world?
It definitely opens up new possibilities.
Well, that wraps up our deep dive for today. We hope this exploration into Azure AI Document Intelligence has given you some valuable insights and maybe sparked some ideas for turning your own document challenges into opportunities.